This is a Research Infrastructure Services instructional video.
So hi, I'm Craig Pohl, and I am the Director of Research Infrastructure Services here at WashU in WashU IT. Um, One of the things that sort of was asked of me is, part of the current state of things with a lot of people working remote is that my team put together a series of workshops and seminars that could, provide access to researchers and staff and potentially students who can become more familiar with the services we offer. And and so this series is what we're doing this week is meant to kind of help facilitate that. So a couple of things before we get started, and this will sort of be a reminder for the various people is, please set your name to first and last name so that we know who you are and we can keep track of who's attended. And if you are on VPN, you might want to log off. VPN may disrupt your performance on your end, so you'll have a better experience if you're not on VPN. Only presenters and moderators will broadcast video and screen share. Sorry about that. And we will be recording the sessions, and we will be making these sessions available. So all the sessions this week. So if you can't attend any of the sessions this week, just we'll edit them and post them, sometime in the weeks to come. Also, any participants, please, mute your microphones and all your cameras. You can ask questions in chat. We have a moderator, Marshall Jansen, who will be helping to facilitate the workshops and seminars. You can also raise your hand if you would like to speak, and the moderator will unmute you. This way we can have, a fairly, productive conversation if people want to ask questions. Potentially, in some of the workshops, we will use breakout rooms for sidebar conversations or assistance that people may need in the seminar or workshops. And if you're not familiar with these, you can get this, if you're in the Zoom meeting, the moderator can assign you to a breakout room, and you can, have separate conversations there. So with that, we'll talk a little bit more about these series and workshops I mentioned. So this is all newly developed content. This is something my group has sort of been working on with regards to the new compute service, which I'll be talking more about later. One of the things we wanted to do was provide sort of multiple formats of this content available for people to use. And we had envisioned, providing, video opportunities for people, along with other text and more traditional formats for people that are wanting to get into and become more familiar with our services that we offer, especially the compute service. So this is all intended to help facilitate the uptake of this service and meet people where they're at. So we realize that the university has people in various places with experience levels. And so we really want to provide a series of seminars and workshops that can build somebody up from not having worked with us all the way to using compute services. And specifically in this case, we chose to use the introduction to Python and GPUs and data science and genomic seminars that were going to be hosted by NVIDIA. We had scheduled these before we all went to remote work, and these were going to be, on-campus workshops. But since we are transitioned to a virtual world, we decided to put this series of seminars and workshops together that would help facilitate anyone who wanted to basically get an introduction to data science and have access to computing environment that would allow you to do that. But some caveats is that the compute service is in a beta for early adopters. So While we want to make sure that everyone has a great experience using RIS services, I do want to throw that out there that we are still scaling and tuning this new compute service. So, please work with us and provide any feedback so we could make the service better. So with that, I'm going to go ahead and continue. So first I'm going to start with a poll. So if Marshall, if you could put up the first question, we're going to ask you if you can answer the question, are you already using RIS services? Yes or no? So I think just about once everybody's voted, we got a few people, 80%, 88% voted. There may be some people who can't vote if they're just calling in on the phone or something, but I think we're about there. You want to go ahead and end that, Marshall? So did you share the results? So it's about 50-50. So that's great. So we have a lot of people that are familiar with RIS services and a lot of people that are new. So that's great. So so let me tell you more about RIS. So we were, as a group, founded in 2017. I was the director of the McDonald Genome Institute and had been for a number of years before we founded the Research Infrastructure Services Group. I started at McDonald Genome Institute in 1997, just out of college, on the Human Genome Project. Part of that program, we built up a large amount of compute infrastructure out of necessity to facilitate, large-scale sequencing genomics program. And to give you an idea, the McDonald Genome Institute has brought in over $1 billion of research funds. So needless to say, my group and what we did, we're always doing things at scale and high performance. And so while we didn't have a large user community, it wasn't new to us to bring these kinds of high performance and enterprise level services to the WashU community. Along with the Institute for Informatics, we partner with them to kind of join forces and merge the, I would say the McDonald Genome Institute is, just a research program where the Institute for Informatics works more in the clinical research program. And this was all envisioned to help facilitate the precision medicine initiative, spearheaded by the Dean Perlmutter of the med school. So bringing our two collective groups together, who at the time in 2015 had operated about 45% of the med school infrastructure, we decided on this sort of portfolio of services that we would offer. And we really like to start with consulting engagement because we really need to understand, what research problem are you trying to solve before we decide, what kind of services will be, best help facilitate solving your research program. But of course, we provide services like storage and high performance computing and data transfer mechanism using specialized networks. Large databases was another thing that we also manage for both MGI and Institute for Informatics. And then specialized research application platforms, and specifically something like laboratory management or other enterprise level applications is what we envisioned that we would provide to the community. So my group is basically set up with 4 different teams. We really like to think of a integrated sort of life cycle sort of management, all the way from running hardware operations in the data center. So we run the research data center on the med school campus. This is where all of our infrastructure resides. So we have a data center operations person, and they do all the hardware installation and hardware operations of running the data center and keeping that hardware up and running. That team works closely and hands off that hardware to our system engineering team once it's ready. They do all the OS and systems configuration, any kind of system security and running systems. So anything at the systems level, system services, monitoring. They do application installation around high performance computing and storage. And then they work closely with the application engineering team, sort of to facilitate sort of what I like to call that sort of, last mile of application services. Although we purchase and run a lot of enterprise level software, there are times that we need to integrate that software or help facilitate, the management of that software as a service. And so that's what our application engineering team does, is to kind of help bridge the gap. And so along with that, they also provide, features for self-service and workflow automation, as a team. And that flows all the way up into our user support team. And we do operate on our own service desk, which you'll find out more tomorrow when Julie talks about that. And we do have our own KB articles and how-to docs and that are specific to researchers in the research community. And our user support team does all of our service provisioning. One of the main things that we try to emphasize as a group, are these, 4 bullet points of we want to operate secure. And that's one of the things that we say can add value, as providing services. Sure, people could go to cloud providers, or you can build your own. One of the added value things that we actually do for the services we provide is security. We work closely with information security to vet all of our infrastructure and operations to make sure we're meeting all the necessary compliance requirements mandated by the type of data or data security requirements. Sustainable. One thing we also learning how to do is run sustainable operations. Having been part of a large research program, we know that there isn't always funds for the long-term sustainability of infrastructure. And so that's one thing that I work closely with university leadership to help fund and operate a lot of this infrastructure. Scalable. It's also important from a research program is that wherever you start out with and using your services, if you're just getting started as a researcher and you're building up your program, you may have just, a postdoc or a graduate student working in your lab, but you may have a vision of scaling that to, a big lab with 10 people or more and lots of instrumentation. So you really want to think about, well, how do I start leveraging a service that can scale with me? And that's something that we are really trying to cater to throughout the university is, from small researchers to large researchers, you can use our services and things will work the way that you expect them to work regardless of your scale. And self-service. One of the things we also recognize is that researchers are all operating sort of independently, and they want to do things on their own time, and they want access and the ability to self-serve. And so we try to provide that mechanism and develop the tools to do that. Another important aspect of our group is that we are not operating independently. There is a research IT governance chaired by Jenny Lodge, the Vice Chancellor for Research, and Philip Payne, the Director of IT. And underneath that executive committee, there are 3 subcommittees. One focused on data policy, chaired by Brad Evanoff and Melanie Rowe, and another clinical applications, chaired by Albert Lai. And then infrastructure and applications, which most of what my team and a lot of the services I'll talk about today have come from is a research infrastructure and applications committee chaired by Dr. James Fitzpatrick. So if you didn't know, this committee back in 2015, before even my group was part of WashU IT and involved in building these services, had developed a research strategy. This strategy was intended to focus on 4 major components in an order, from networking to storage to compute and enterprise applications. And the point of this strategy was to allow faculty to focus on research and not infrastructure. And as kind of I mentioned, it was also focused on meeting the continuum of user needs throughout the university. So you can, meet researchers where they're at. And ultimately, this is to reduce risk exposure and inefficiencies of distributed systems. And I'll talk about that with respect to the data storage platform and how that's helping to facilitate research. And provide value, and again, to reduce complexity and decrease time to discovery. And ultimately, the goal is to increase institutional funding competitiveness. It is, an expected sort of requirement now that funding agencies want to see universities helping to facilitate researchers with these kinds of services that we're offering. So I'm going to have another poll that people can answer. Do you have a research instrument that produces large data files greater than 2 gigabytes? Okay, you want to go ahead and stop the poll, Marshall? Looks like we got most registered and share the results. So it looks like 68% of people online have an instrument in their labs that produce large data files, which is great. And so, so the WERN, go ahead and remove that. So the WERN is potentially something that could help, is why I asked the question. So the WERN was implemented in 2017 as part of the large research strategy as a high-speed campus science DMZ. This is meant to facilitate the transport and dissemination of big data both within the university and outside the university. So there was a 40 gigabit backbone between both the medical campus, the medical and main campuses. And there's a 10 gig dedicated interconnect to internet too. So this allows you to move data across the university and outside the university. Another aspect of the WERN is it provides on-ramps, which is basically local building solution to facilitate large instrument data producers. And so what we've done for the McDonald Genome Institute and the WashU Center for Cellular Imaging and a couple other locations is actually build these building on-ramp switches, because they are instrumentation that wants to move their data from their instruments to storage quickly. And so this will bypass the firewalls around campus and move the data directly to storage. Thus far, we've had over 82 devices attached to the WERN network. And what does that mean? Most of these devices are in a data center. So people have, attached their storage servers or their endpoints to their local computing environments that will allow data movement outside the university really quickly. And as I mentioned, the 3 building on-ramp switches to move data within the university rather quickly. And this is represented by 11 groups. And those 11 groups are not PI groups. They're a mix of sort of departments and sort of buildings, because, people have, like the Couch building contributed to a shared building on-ramp. All right, I'm going to move on to talk about this data storage platform. We have a couple of questions here. Where do you currently store your data? And check all that apply. All right, looks like we got a good distribution of local department storage. I got, about a third of people using RIS storage already. A lot of people using Box. Box has been a really popular addition at the university. Uh, Even though it's free to everyone, it's not free. It is something that is being funded by the uh, by the CIO's office, and people are using the cloud and other solutions. Maybe they got some old zip drives or USB sticks that they're using. But yeah, that's great. All right, so I'm going to talk about the data storage platform. Oh, that's right. We have another question here. Let's see. Have you had any issue accessing your research data during this pandemic? All right. Looks like we got almost everybody voted. Um, Looks like some people have had access, had issues accessing their data. Um, I bring that up because that's one of the reasons that we built the solution that we did from the beginning. It is the RIS storage platform has been accessible, both on campus from any network and off campus via VPN. So that you can always have access to your storage no matter where you're at. So what is, at a very high level, what is the data storage platform? It really is quite simple. With your WSDL key, you just map a drive. What we've employed is a common URI. And so what does that mean? Well, so SMB is the protocol that we allow you to mount and communicate to the storage platform, to our servers. And then the way we've organized the data, since each researcher is getting 5 terabytes of free data, we needed a way to categorize that. But also it's a way to know and easily discover somebody's allocation is a PI WSDL key. And then underneath that, we have different tiers. And so to easily identify the tier of storage that you're using, we have that mapped in to the hierarchy. And then after that, we encourage people to create project directories or user-based directories such that you can apply ACLs. And what does that mean? That means that you can share a directory and allow other people to read and write to that data. So a good use case is if you are operating a center like the McDowell Genome Institute and doing a lot of sequence generation for groups, you don't want to end up owning all the data that you generate. And you don't necessarily want to have the people to come to your compute environment to analyze that data too. So what the storage platform allows you to do is generate data and get access to a PI's allocation who is ultimately responsible for that data. And write it back to their allocation so that they can manage that and determine, what data to keep, what data to get rid of, and that should be part of their research program and their data management plan. And so what kind of data can you store? Almost any type of data, really, just in general, images, text files, and confidential data or ePHI has also been approved. And again, because we work closely with information security. Although this is for general research data, we are on the secured network and things are been locked down. And part of the ACL management is access control is all integrated with WSDL key, such to meet the compliance requirements for storing ePHI. So I talked about some of the features already, but other things to note is, as I mentioned, scalability. We provide a tiered cost model. You can start out with your 5 terabytes of free storage, but you can grow that as your research program grows. And so you only pay for what you use over 5 terabytes, and we can automatically, change your allocation amount. So you can start with 5 terabytes today, and in a year you can change that to 10, but you'll only get billed for what you're using between 5 and 10. And then once you get up into the, tens and hundreds of terabytes, we think of 100 terabyte or more a subscription level, because that's a fair amount of storage, and what you do with that storage could impact not only performance, but our ability to provide that storage. And because you're a larger consumer, we give you a discounted rate. So we would like and prefer to move you to a subscription model. So it's a more fixed cost and more predictable model that we can ensure you have the storage you need. And then ultimately, if you get up to 500 terabytes, we provide what they call a condo model, where you can actually purchase the physical disk to support your research, but pay a fee for actually using the service, such that your costs are fairly low, but you get the added benefits of backups. We do back up the entire file system. We do change and keep those changes for 90 days, and that's on our active tier. And then our archive tier, which is basically what we consider nearline storage with a mix of disk and tape, allows you to easily move data from one tier to the other, because it's really just another file system. And the data automatically moves from different tiers on different physical tiers behind the scenes, without you having to do any of the sort of management or legwork. And I did mention that we ensure that data compliance and security controls meet all funding data management requirements. And this is just also a shout out to the libraries. The libraries on both campuses offer a data management tool that you can, when you submit your grant, that you can register your data management plan, such that it will state how you will use the storage service and maintain this data as part of your research program. And they also offer data curation services too. So post actual grant, you can come up with a plan and how you're going to store this data long term, which is a mention to one of the tiers that we're working on is the cold tier, which is ultimately a place where you can store data that you don't need access to, but you need to hang on to it for compliance purposes. So some stats thus far, if the people that are already using the storage platform, we have 581 allocations thus far, and we have 555 faculty PI allocations from 95 unique departments across both campuses. And the reason why we have sort of the number of allocations is greater than the number of faculty, because we can and will create allocations on a department or center level. You don't get 5 terabytes of free storage, but you can get sort of a uniquely named allocation, say for your center or for some other use that can be maintained independently. So within there, we provide access to over 2,000 total users of the system. We will continue to grow the amount of space we have. We have 2.5 petabytes of data consumed now in almost 2 years, and we have a total of 8 petabytes of active space available. And that has been increased because we have 2 petabytes of active space condos that people have purchased in the last year. And then our archive tier is really starting to get usage as people consume their 5 terabytes of free and start to move their data down to the lower tier. We have 261 terabytes of 4 petabytes available in the archive space. So I mentioned the cost model a bit. So what does that look like? It's $15 a terabyte per month in your consumption level, less than 100 terabytes. For the active tier, the archive tier is about half the price at $8 a terabyte per month. And then the subscription, as I mentioned, it goes down to about $10 a terabyte per month, but you are paying in 100 terabyte increments. And so this allows you sort of some more fixed cost rates, as I mentioned. And then again, the archive is about almost half the cost. And then ultimately, yeah, the 500 terabyte increments is for large users of condos. And what you pay is this $500 a month for operations. And again, so you are getting 500 terabytes of usable space, but you get all the added features and benefits of using this central service. And archive tier, you actually buy 2 copies of tape, because ultimately, if the data goes to archive and it goes to the lowest tier, we store it on 2 copies of tape, so that you always have a double copy in case something would happen to that tape. And the current cost of a condo within the active portion is about $85K, and the archive tier is about $15K. So if you're wondering what those costs were. All right, now we're going to ask some questions about the scientific compute platform. Let's see, the first question, where do you currently analyze your data? And select all that apply. All right, I think that's just about everybody that's going to vote. Looks like we got some existing compute users of RIS, and that may be people using our MGI cluster. We have people in this Center for High Performance Computing, and we have some HTC users, the high throughput computing and genetics. And a lot of people look like using local or department computing. We have some people using cloud already, which is great, and then other computing. All right, all right. The next question I have for everybody is, have you had issues with your analysis have you had issues with your analysis application completing in a reasonable amount of time, 24 hours? So basically, does your current compute solution, is it working for you? Right. Looks like we're almost split. It looks like some people are having issues with their analysis completing in a reasonable amount of time. That could be, maybe your analysis just takes that long, or maybe you need supporting infrastructure to help facilitate maybe parallelization of that application or access to more resources. All right. The last question I have is, have you had issues accessing your compute to analyze your data during this pandemic? Right. Looks like some people have had issues. A lot of people haven't. I suspect that, maybe VPN access to your compute is part of the problem, or maybe your compute is, still, underneath your desk, in your office on campus, and you maybe not have access to it. or maybe it's just something that, you know, that can't be moved to a data center or something. So there's various reasons for, you know, that occurring. But one thing we are trying to do is make sure the services that we offer are available, you know, to you wherever you are. So I'm going to give you a bit of a brief, very high-level introduction to our scientific computing platform. And this is really meant to be, you know, a very high-level just description of what we're trying to do, just to demonstrate, you know, what we're doing and how we're, you know, being forward-thinking about building out our compute platform and capabilities in the future. We are not simply just building a high-performance compute cluster. We really are looking at building an integrated platform. So, so as I talked about, everybody that is using RIS storage, we have these different available tiers, and we provide them over SMB interfaces. So wherever you are, whoever you are, you can access that currently. And so that was part of this larger infrastructure and architecture that we were building, is to provide you an interface to access that, that storage on high performance compute infrastructure. So if you're coming, depending upon who you are, you can come in to our platform. Yep. Marsha, are you drawing? Not sure where that came from. Okay, so Open On Demand is a web-based interface that that we are going to be working on building to provide a web-based platform to access compute. So if you're not familiar with command line, and we're going to introduce you to that this week if you want to, and it's still something that you may want to pick up, but you know, we will offer that. So we do run the IBM Spectrum Scale, which provides an SSH client to log into our cluster and submit jobs. One of the important things that we're doing is containerizing your applications to help facilitate the reproducibility of your science and portability of your science, so that you can build it and maintain it and take it with you wherever you want to do your computing. And another important aspect is that we're going to be building into this infrastructure is this Kubernetes application orchestration component, and other workflow engines like the Common Workflow Engine platform is what we'll be integrating this to help support the different kind of computing needs that people have in the different on the different computing options that you may want to leverage. So that could be on-premise. So we, I'll review in more detail, have built a new on-premise cluster. It's right behind me in this image. It's an image of it. So we have this new large on-premise compute cluster. And then we also have integration with Google Cloud Platform. So maybe you are doing some initial pre-processing of data off your instrument, and you want to store that on and do that locally in a data center, but then you want to take that data and easily access it within the Google Cloud Platform or AWS, and we'll help provision projects for you in those environments that will allow you easy and secure access to that storage, so you can use their analytical tools for your analysis. And you know, all these are interconnected through high performance networks. And so what we've been doing, working with Google, we have a dedicated 10 gig interconnect to Google now, so that we can easily move data from our storage clusters up to Google for processing. And then we also have a very high speed, low latency, high bandwidth interconnect called InfiniBand HDR that allows very quick and high performance access within the cluster. And this is all done through a caching layer. So if people are familiar with traditional computing clusters, is that you typically have to manually move this data from your sort of your active working data to a cache layer to work with it, or a cache layer or a staging layer within your compute cluster. So within our environment, we don't need to do that. We have we have storage integration that allows us easy movement and automatic movement back and forth between these two clusters. And we also provide high performance scratch space on our local cluster. This is basically like a global temp space. So if you're familiar with high performance computing environments, they typically will have something like this. So that's the general very high level architecture of the compute platform. As I mentioned at the beginning, we are still in a beta early adopter mode, but we have completed certain features already. We have integrated with WSO3 directory service. Every person that has access is a member of a group, and you can be a member of multiple groups, and all this is integrates with your RIS storage allocation too. So when you submit a job, you not only need to specify what container and application runtime you are running, but you also need to say, you know, who's basically responsible for this computing. Because we have a lot of people that do analysis for multiple research groups, they will have the ability to specify basically what compute they're consuming for what purposes and what storage they're accessing, all within a single job. And that's important, again, for security, for keeping track of who has been accessing what data with what applications. And I see there's a question about when will compute be PHI compliant? We are working with information security right now. We actually have, we provided our initial architectural diagram, and we did an initial review with them. They are coming back to us with questions, and we have a meeting later this week. We expect that they'll want to see certain things implemented and other things implemented and documented. So we'll have some more additional work to do once they come back with their requirements. But again, because you know, a big part of security is storage, and we feel like that we have done an extremely good job securing the compute environment. One thing that we've done in this compute environment is actually it's all SE Linux enabled. That's secure Linux. And so what this does is that, again, you're running a containerized environment, but you can't break out of that container. And every process within the Linux environment that you're running, you know, is basically categorized and controlled. And so we can limit people's ability to do inappropriate things within the cluster. And it's really cool because you can be sure that everything you're doing, even if it's just general research or you're doing HIPAA compliant research, that your data and your information is being securely segregated from the rest of the cluster community. So other things that we plan on doing for mid to late 2020 is actually the integration with GCP. So we actually have the GCP connection up, and we are provisioning GCP projects and working on a process to automatically provision these projects in a secure environment for ourselves. And as we develop that process, we'll be handing it over to provision this for the research community. And I already talked about the HIPAA compliance timeframe. So thus far, we have 260 servers, and these, you know, sort of the specifications on these, each of them have 2 Intel Cascade Lake 2.8 gigahertz CPUs, each with 16 cores, 384 gigs of RAM, and 100 gig HDR connections. An important thing to note is that this network is a one-to-one network. So what does that mean? That means communication for every node in each cluster has a one-to-one bandwidth connection. So there are multiple routes in a spine leaf network that allow this to function that way. That means a single server can have complete access to high performance storage also within this environment. So thus far, we have over 8,500 CPU cores, and the initial investment by the university was 5,000 cores. So we have almost included 4,000 condo cores. And so it's 4,000 because we have some cores that actually haven't been included in the cluster yet. They've been ordered and they're being installed now. We have 120 NVIDIA Tesla V100 GPUs, and 20 of those are condo GPUs. And we have 3 terabyte large memory machines. So I know a lot of people out there, need access to these large memory machines, and so we've invested in 2 of those, and we're looking, sort of as a next round of upgrade of infrastructure to increase those, the capacity of those also. Thus far, we have 63 faculty PI groups in 29 departments helping us to flush out sort of the beta early adopter use case and performance testing. And this is 274 total users. And so we are seeing regular, daily usage of the cluster now. And we have had, 5,000-6,000 jobs running at one time, pushing performance. So we are getting good performance testing. So one thing to mention for CHPC users, what does this mean for you? So we've been working on this and what we're calling a traditional computing environment in a Docker container. So what we are trying to do is help this transition for you easily by providing the environment that you're accustomed to, and so that your research can continue without having to do a lot of heavy lifting. So this will hopefully provide the command line or web-based interface to the cluster that you're accustomed to. And other things that we're also going to be able to do within this cluster is provide SAS and Intel compiler level licensing, and we're working on MATLAB too. So another important aspect of this centralized resource and what we're trying to deal with is the centralization of licenses. So we know a lot of research groups are purchasing licenses and they don't need them or use them 24/7. So it's a lot more efficient if we can purchase a pool of licenses and share those on the cluster. And those will not be any additional costs. It'll be part of the cluster fee that is included. So other things we've been doing to help facilitate this is we've hired a research facilitator dedicated to onboarding and training the user community. So that was part of our capital project, and her name is Ellen, and she's going to be giving the Compute 101, 102, 103, 104 seminars on Wednesday. So she's been a great addition, and like I said, this is all fairly new content for a lot of us, and we're coming up to speed on getting these seminars and workshops out there. Other things that we know that are going to be issues for transitioning is storage and data paths, mapping. So you're going to have to move your storage if you do have data on the CHPC cluster, and so you'll have to move it to your RIS storage. The cool thing is that within Docker, you can map your storage volumes so that your scripts are still referencing their old locations while you're mapping it to the new location within the Docker container. So we can show you how to do that. Other things that you're going to have to do is upgrade or change your job scheduler. It really is just a mapping of commands. So if you're using QSub now, it's going to be a BSub or other similar command, to find resources or submit jobs. And transition of billing services. I know a lot of departments, pay the fee for a lot of the researchers, but these fees are all going to be waived for FY22 because we do have a different cost model than the CHPC, again, to meet researchers where they're at as far as their compute needs. And so, although we are not charging until FY22, this will give you an idea and an ability to use the cluster over the next year to develop your use case so that you can appropriately select the usage tier that's going to meet your needs. So what do we have? It's a general access fee, which is $100 per FTE annually. And so this will basically provide you the same sort of access and usage that you currently get within CHPC or other sort of general shared computing environments. So fairly cheap, but with the ability to scale up if you need to. And so we provide subscription tiers. And so the subscription tiers will basically provide you dedicated access to, 25, 50, or 100 cores, depending upon what your computing needs are. And it's sort of tiered with the GPUs too, because we have a lot of GPU capacity and a lot of interest in those. And then ultimately, you can scale up to the condo. And we actually have a lot of people who have already purchased condos because they know they have dedicated compute needs. And so basically, if you're going to need over 100 CPU cores, or if you want to just buy, because you have capital, invest in this condo, you can guarantee you'll have the resources you need when you need them. And you can, we'll work with you to get the kind of resources as far as compute and RAM needs that you need in your compute too. So condos, you get a little bit more flexibility as far as the build of the system. And then ultimately, we'll provide a consumption tier too. And so what is this? This is much like any cloud where it's just on-demand resources available. And so you just pay a flat fee for general consumption, nothing too complicated. We don't want to make this difficult, but we do want to help facilitate researchers when they, need increased compute, say to write a paper or to submit a grant. And so all this will, all these different tiers will help, provide researchers the compute that they need. All right, so that's it on compute. I'm going to mention a couple of other things as far as research applications go and wrap things up. So we do have Globus platform, Lab Archives, or RedCap, and I'm going to talk a little bit about more of those in a minute. But so as I mentioned, we do support the infrastructure for the Institute of Informatics. And I think that's important as researchers start bringing the different types of data together and start working across the clinical and general research areas in say like genomics. So there's the RedCap platform for building and managing online surveys. We support the Research Data Core. So if you didn't know, the Institute of Informatics has a data brokerage service, which you can go to them to ask for data that is in the EMR, so the Epic EMR, they have a data feed from BJC, and they curate that data and manage that database. And so you can go to them and tell them what kind of data you're looking for, and they can extract that for you. And then another thing we're doing with them, with the Institute of Informatics, is setting up an MD clone platform, which is basically generates a synthetic EMR from the actual data. So this is something that's been under proof of concept. So this will allow you to bypass IRB to see if there are data sets that meet your qualifications for your research programs. And then the other thing I'm going to mention and go into a little more detail is ITSM platform that we're building. So Globus, what is Globus? And so this is something that will be useful for people coming from CHBC or has proven useful for other departments moving data in. So if you have a central place where your storage already exists, you can connect your data storage platforms. That means you can connect your existing department storage platforms to our storage platform and move data. And so if you're familiar with things like rsync, or RoboCopy, it's similar to something like that, but it's a web-based client with its own protocols for quickly moving data between data storage platforms and securely. So you connect those systems via your Globus client. And so this is something you can also do without. So we have an enterprise license and a storage server that fronts our storage service, but you can also share data using this system. So you can share data via the Globus platform. And other things you can do as you move your data in to RIS, you can build other custom portals or science gateways or do other workflow automation with Globus. They provide a REST API and Python SDK to create whatever kind of platform you need to meet your research data management. All right, Lab Archives is another thing that the university has invested in that came out of governance. The university really wants to see people move to an electronic lab notebook. This is available to anybody. If you just go to Lab Archives, it'll ask you to sign on with your Wilstal key. You can manage and curate your research projects, and it does tracking so that each edit and change within your research lab notebook keeps track of who's edited when, it's compliant for EPHI. It has a limited storage capacity of 250 megabytes, but we have integrated it with the Box platform in the back end such that larger files will automatically be stored in Box. It doesn't go into your Box private account, but it does give you the ability to load larger files within this environment if you would need. We have people using both the RIS storage and this, depending upon the type of data that you have. You can link and reference your RIS storage in this platform also. They have an application, so if you're it's a web-based app, but they also have apps for your phone or tablet. So if you're working in a laboratory environment, you can be taking notes, taking pictures, and uploading them directly to your electronic lab notebook. And the other thing they also provide is a DOI. So if you want to actually publish your lab notes and your results, or document and put controls around them such that they're referenced for future purposes, you can also do that within this platform. The other thing that this offers is a classroom edition that integrates with Canvas. So if you are giving if you have, traditional labs, like say in an undergraduate course, you can also leverage this platform for labs for students to do and collect and report their work and ultimately grade it within this platform. So I mentioned self-service and service management is something that we strive as part of RIS. And so one thing that this is a proof of concept that we're working on is a dashboard for researchers to help facilitate the management and self-service of some of the things that we're currently doing for you, say like ACL management. If we want to work that into the storage platform so that you can control your own ACLs and they're all properly recorded and logged, we're providing a platform to that. You'll see your billing and reports, so your administrative staff that want to know how to fund this, it'll be a place for them to go. Also. And so we're really trying to complete the life cycle and integration of all these different platforms into one place so that you and your research lab can really know who's consuming what, when, and what those costs are. So that kind of wraps up my talk for today. There's my contact information, and we are putting all the materials this week in a Box folder, and we will be sending out the link to the presentation today. But with that, if there are any questions, I'll let Marshall sort of jump on here and control, and I'll try to take any questions. Marshall, are there any questions?
Okay, I'm unmuted. We've got one question on how to access the ITSM dashboard.
So that's a proof of concept that we haven't released yet. We have identified many features and things that we need to productionify before we release that. I think the application engineering team is kind of heavy in the mix of getting users onboarded to compute currently, which is great because there's a lot of things that we want to integrate from a self-service ITSM management perspective for compute. And so it's giving them the opportunity to get experience with that. And we're probably looking probably more, late summer, early fall for an initial release of that platform.
That's all the questions we have so far. Lots of thank yous though, so that's good. I'm glad it was a great presentation for everyone. So if we have any more questions.
Let's see, I see one. How does RIS-mounted disks work outside applications such as RStudio? Yeah, so RStudio, so it's something that you can run on the compute cluster. And so, yeah, one of the things I mentioned, like within the compute cluster is you could start a RStudio container and mount your storage. And if you go through the workshops, you can learn how to do that. this week, and we will have documentation within our user manuals on how to run applications like that also.
And Jason has a question about MD Clone, the synthetic EMR. Do we have dates on that?
So that's been sort of development proof of concept. We are currently doing, we're actually evaluating the sort of cost for where we want to run that in production. It was currently developed in Azure, and it's a fairly large infrastructure that is required to run that operation. So we're trying to do some cost estimates and find some ways to find some savings on how to run that. And yeah, I would go to the Institute of Informatics and follow up with them if you want more specifics.
Okay, I don't see any other questions at this time. That looks like it.
All right. Well, thanks everybody for attending today. Really appreciate all the interest and you know, answering the poll questions. And don't hesitate to reach out and sign up for any of the other workshops this week for how to work with us and how to use compute and only using GPUs and Python.